Okay, so the last little bit that we need to talk about on the dot diagram thing, in previous class earlier this week, we looked at making Lewis dot diagrams for both ionic compounds and covalent compounds, and we're going to spiral back and look at a few more examples of those before we're done here. But one more thing we need to talk about, and it's toward the bottom part of that second page there, and that has to do with what are called diatomic gases. Okay? Diatomic simply means two atoms. Okay? Most of the elements on the periodic table are capable of existing as just a single discrete atom not bonded to anything else. In reality, that very rarely happens because most of the time if you have one atom, you're going to have a few hundred thousand. Okay? But at least they could exist as single atoms. These 7 elements never exist as single atoms, or super rarely. They usually go around in pairs, paired up with themselves. And that would be H2, hydrogen gas, O2, oxygen gas, F2, fluorine, Br2, bromine, I2, iodine, N2, nitrogen, and Cl2, chlorine. There are very rarely things in chemistry that you just flat have to memorize, and I'm afraid that this is one of those things that we just flat have to memorize. But I'm going to try and give you a couple ways to help you remember these 7 things that always go in pairs. I had a colleague I used to teach with, and she came up with a little mnemonic device. Don't write this on your paper where I'm writing it. If you want to write it somewhere else where you got some space. Help our class find its brain now. Okay. Hydrogen, oxygen, fluorine, iodine, bromine, nitrogen. I think that's lame, but if that sticks in your head, awesome. The way I prefer to think of it is I prefer to think, what if you had a very large German man and he had to sneeze? Okay? And I think large German man because, you ever seen the video where they do different words and they do it in different languages, and then when it gets to German it always sounds violent and angry? Okay? So, just like anything else, I imagine that a large German guy would have violent, angry sneezes. And so, we would go, achoo. Okay? If you're a large German man, you're going to go, ha, because, that's what angry German guys sound like. And so, imagine some angry German guy sitting in a restaurant and goes, ha, the other one says, and he goes, thank you very much. Okay, so that's, kind of how it sounds. What the heck? Ha, Sprinkle. See? It's like a big German guy sneezing. And that's another way to remember it. I wrote it over there instead of in the blank because I write too big. If you can fit it in the blank, fit it in the blank. If Sprinkle's not going to work for you, then just, help our class find its brain now also works just fine. If you can find another way to remember it, all the better, because then you're the one who thought it up. And then, of course, don't forget the whole point of this is all of these always go in pairs when they're by themselves. They're never really by themselves. And so I have a few examples that I wanted to look at down here. I'm going to say hydrogen gas for you because hydrogen gas is way too easy. But I wanted to look at oxygen gas. So just like we did yesterday, now these are both going to be, since oxygen's a nonmetal, it's a nonmetal atom with another nonmetal atom, so they're going to be making a covalent bond. Furthermore, since they're the same atom, they've both got the same electronegativity, the same degree of attractiveness, and so they're going to be sharing those electrons perfectly in between the two of them. So, just in the back of my head, I'm going to be picturing that I've got oxygen atoms that have how many valence electrons? Your periodic table. 6. And how are they arranged? Pair, single, Very good. So, I'm imagining this in the back of my head, and I'm thinking, if I've got 2 of these, they've got 6 electrons to start with. How many more does it need to be stable? 2 more. So So how could two of these share electrons in such a way to where they both have access to 8?
They all have 2 electrons. They can share that.
Right. They're going to share these little single electrons right here with each other. So what I'm going to have is I'm going to have one of my oxygens. He's got single electron, pair, pair. Okay. The other one, single electron, pair, pair. And that works just fine. We want to snuggle them a little bit closer together. There we go. So we can see that there's a pair there and there's a pair there. If I was drawing this using the other, how could I draw this showing those pairs instead of just dots? I could use lines. Okay. So it could also look like this. Let me move all these guys out of the way real quick. Come on. And 2. Can I make that one? No? Yeah, that's good. What? Okay. Never mind, let's do it. Okay. So I have an oxygen. I'm sharing 2 pairs. I'll put 2 lines. Each line represents a pair of electrons. And I still have to show the unpaired dots. So each one's going to get 2 pairs like that. Okay. Either way is fine. Okay. Now if you'd like to draw those, go ahead and draw those. I'll work one more for you. Let's take a look at fluorine, F2. Thinking in the back of your head about fluorine, how many valence electrons does fluorine have? Not have 9.
7.
It has 7 valence. 9 total. The 2 are on the inside, so we don't count them. So they're going to be pair, 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 single, right? So how many more does fluorine need? 1. So how can 2 fluorine atoms share in such a way where they both have 8?
They share the 1.
They can just share the 1 single that they both have. So this time I'm going to do it with the lines first, and then I'll come back and I'll do it the other way. So here's fluorine. There's the other fluorine. They're going to share a pair of electrons between them, so I put 1 line. And then I have to show their other pairs. They're not being shared, just like that. If I did it the other way, and here's a fluorine, bless you, pair, 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 single. Here's the other fluorine, pair, 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 single. So there's the pair that they're showing. This is an excellent place for questions. If you have one, please ask. Yes, sir.
So the lines, like that one is 1, that one is 2. Since they're sharing 2, it's 2 lines.
These guys are actually sharing 4.
Oh.
They're sharing 2 pairs. See, each one of these pairs is a line. Okay? Whereas this one, this pair, is that line. Okay, good question. Anybody else?
May have to deal with another problem. I'm confused on nitrogen.
Okay, I'm not going to work nitrogen code. I'm going to let you work that one on your own in just a minute. Just to make sure that everybody's still kind of on the same brain page, I do want to go back and look at the ionic side. That Or it's going to do one of those things, okay? Do that way.
You can do a circle and cap it.
Okay, typically I could, but see, it can't make up its mind if it's going to be tracking my ink stuff from the smartboard stuff or if it's tracking my ink stuff from the recording software. It kind of is a little bit bipolar about it. So the stuff that it's doing, see how those are fat lines and those are skinny lines? Watch this. See my problem? And I know the big circle and the tap thing. I've been doing this since you guys were in diapers. Come on. That sounded arrogant. Okay, so let's come back and how about this? See. Okay, so I worked those three for you the other day. Let's take a look at these three right here. We've got calcium fluoride, sodium carbide, and aluminum carbide. Which one of those would you like me to work for you?
1G.
You're going to vote for 1G. Anybody disagree? All right, let's look at 1G. Because, you know, logic dictates that the further down on a page it is, the harder it probably is, right? Sometimes that's true. These aren't really hard. So we're talking again about ionic, so just to get your mind in the right gear with ionic, you have a metal and a non-metal. The non-metal is stealing electrons. And what happens when you steal?
You get locked up.
You get locked up and charged. So we're going to see atoms get locked up and atoms get charged. Now I'm going to do this a little bit different. I'm going to do it in my head so I don't have to like rewrite and move things around. So I'm going to think about aluminum atoms. And I'm going to think aluminum atoms have how many valence electrons? They've got 3, right? Pair and single. So just kind of imagining that in the back of my head, and I'm going to have 4 of those. What about carbon atoms?
4.
Carbon atoms have 4, right? So here's carbon, because it's 4, and I'm going to have 3 of these. Now, which one is the non-metal? Carbon. So the electrons are going to be going to the carbons. How many more electrons will each of these carbon atoms need?
4.
They're going to need 4 more, right? And you can go one right there, right there, right there, and right there. So what I'm going to do is I'm going to go draw my 3 carbon atoms over here. Carbon, carbon, carbon. I'm going to go ahead and give them the electrons that they're starting with. And then I'm going to go ahead and give them the electrons that they're going to need to steal. So they're going to need to steal 4 each. So there's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, where did they steal all these from? They stole them from the aluminums. And I've got a total of 4 aluminum atoms over here. Al, his brother Al, his cousin Al, and their sister Alice. Okay? They had 3, now they don't have those 3. So what kind of a charge will each one of them have? Positive 3 each. So I'm going to go ahead and write plus 3 on each of my aluminums. Now my carbons, they stole, so I'm going to lock them up and charge them, right? Over here and put them in brackets. What's the charge? How many counts of electrons does each of them have?
-4.
4 each, right? So -4, -4, and -4. Now, the 2 things that I do to check to see if I did it right. First of all, I look at my negatives. Do each of my negative ions have 8 electrons around them?
Yeah.
Yes, they do. 8, 8, and 8. We're good. Do all of my charges add up to 0?
Yeah.
Okay. And I can check that because positive 3 times 4 gives me a total of positive 12, right? And then negative 4 times 3 gives me a total of negative 12. And those would cancel each other out and give me 0. So I know I've done it right. Again, does anyone have any questions? This is only true if you have an ionic bond. If you have a metal, bonds to a non-metal. The only way to know that is to look on a periodic table and see where they are. Metals are on the left, non-metals are on the right. Let's go back to the other side and let's look at another covalent example or 2. That's not bad. Yeah, you're going to do good. That's fine. So, possible. So possible ones that I can work for you, I can work 2C, 2D, 2E, or 2F. Okay, here are both for 2E. All right, I'm liking that one. I'm really glad you picked 2E because this is really good for me to teach you a new thing. So we're going to have CH3Cl. So I'm going to have one carbon atom, 3 hydrogen atoms, and 1 chlorine. So in the back of my head, I'm going to go ahead and put down what they're starting with. Carbon is starting off with how many valence electrons?
4.
4, right? So it's going to have 4. How about hydrogen? Hydrogen's going to have 1, but I'm going to have 3 of those, right? And then chlorine's going to have how many? 7. So how am I going to get these arranged where everybody gets what they want? Now, hydrogens only need 1 more each, right? Because they're hydrogen. They're small, they just take 2 to be satisfied. Carbon's going to need 4 more, and chlorine's going to need 1 more. How the heck am I going to put these together? It is like a puzzle. Let me help you out with one of the pieces. So carbon does a special thing. And I'm going to kind of write this over to the side here. Don't do what I'm doing right here because that's going to screw you up. Carbon, typically, if you just look at its valence electrons, it's got pair and 2 singlets. That's because it's in energy level 2. And so its valence electrons are 2s2, 2p2. And in the orbitals themselves, you've got 2s, electron, electron, and you've got 2p, electron, electron. So that's the pair, and that's the 2 singles we're seeing right there. In certain circumstances, the elements that are in group 14, carbon, silicon, germanium, tin, and lead, when they are forming covalent bonds, this electron right here does something funny. It actually jumps over to there, where it's not there anymore. Instead, it's right there. And so instead of carbon looking like this, it looks like this. Single, 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 single. Now can you tell me how we're going to fit everything on here?
Mm-hmm.
Who's going to go in the middle?
Carbon.
Carbon goes in the middle. So let's do carbon in red. So carbon is going to have 4 single electrons. It needs 4 more. Where are my hydrogens going to go?
There's 3 of them, so
Up,
there's
down, and
going
left.
to be 1 on
Right.
3 of them.
There's going to be 1 stuck to 3 of these. Okay, so I might put a hydrogen right here and have him bring his electron. I might put a hydrogen here and have him bring his. I might put a hydrogen here and have him bring his. So what about my chlorine?
You guys want to go to try that one?
He's still got his single. He's got space for 1 more right there. So I'll have him come here. He'll bring his pair, 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 and single. Now look what we got. Does each hydrogen have 2? It's happy. Does the chlorine have a set of 8 now? It's happy. Does carbon have 8?
Yes.
Everybody's happy and nobody had to steal from anybody, right? Okay? So if I was going to do this in the little simplified diagram, how would I do that?
You do an arrow to chlorine and
Oh, I don't need to have any arrows.
or a line.
Carbon's in the middle. He's got a pair shared with this hydrogen. He's got a pair shared with this hydrogen. 1 shared with this hydrogen. And he's sharing a pair with this chlorine. This chlorine also has 6 dots around the outside. So that would be the other show. Questions?